This is the CBNG 1001 Orifice lab presentation. Right, in this presentation, I'll give an introduction of the lab. I'll outline the procedure that would have been used in the lab if you yourself were doing it. So in general, this lab is based on the hydrostatic concepts of fluid mechanics. And what is critical here is to understand that the discharge velocity out of a column of water is related to the hydrostatic pressure present at the discharge point. And the discharge velocity at this discharge point in turn affects the trajectory of the emergent jet through the discharge point. So this laboratory exercise investigates such relations between the hydrostatic pressure and discharge velocity via the HM 150.09 orifice and jet velocity apparatus. So here we can see the water column where we have a water height of h. The pressure at the exit point is P, and the velocity of the water exiting the exit point is given as V. Alright, now the discharge point is termed the orifice. The orifice is nothing more than an aperture by which the fluid exits through the water column. And what this lab seeks to impress upon you is that the trajectory depends upon the velocity which exits the orifice, which in turn depends upon the pressure at the exit point of the orifice, and this also is in turn based upon or dependent upon the height of the water within the water column. Apparatus used to investigate these objectives is HM 150.09 orifice and jet velocity apparatus. And the parts that are relevant or important to us are firstly the pump, which provides the hydraulic bench or facilitates the hydraulic bench, the orifice fitting device and the entire hydraulic bench system, the orifice nozzle which will be inserted into the orifice fitting device, and most importantly, the jet trajectory probes and trajectory panel. So now that I have mentioned the fundamental equations and the derivations that I expected of you, we return to the procedure, which is nothing more than firstly inserting the orifice into the orifice fitting device, then starting the pump and adjusting the water head to the desired height. And in the first case, the height is given as 250 millimeters. Thirdly, we then adjust the trajectory probes until the jets barely contact the jet at the fixed X positions. Fourthly, we then read and record the X positions and the Y positions, and these Y positions that you are reading and recording is the measured ones. And finally, step 5 will be to repeat steps 2 to 4 for two other heights in the water column equivalent to 300 millimeters and 350 millimeters respectively. This is the video of the lab being conducted. The entire procedure, which was on the previous slide, is outlined here, where we see the orifice nozzle being inserted into the fitting device. We then see the equipment being plugged on and the pump being switched on. And you can see here that the water is being allowed to build until it reaches the desired height within the water column. Right, so we see the water height building slowly, and eventually it will reach the equilibrium position, which is the 250 millimeters in the first waterhead being investigated. So we still see the waterhead is building, right, until it reaches the 250 millimeters, which can be identified by the small hole in the red cylinder. Okay, so now we can see that the waterhead has reached the desired height of 250 millimeters and it remains at this equilibrium position. Now the next step is being executed, where the trajectory probes are being adjusted to just barely touch the top of the jet trajectory. So here we see the first probe being adjusted, and it is important to know that the probe must barely touch and should not interfere with the trajectory further downstream. And the second probe is now being adjusted. Moving on to the third. Fourth probe is now being adjusted. Fifth. Moving on to the sixth probe. Which will then be followed by the seventh and the eighth probe. Now what is important to note here is that the final probe, the eighth probe, would be unable to touch the jet trajectory, and this is a limitation of the apparatus. So in your results, you will see that the eighth probe for this specific height of 250 millimeters would have this note, this notes in the results. We then go on to the next step where we will record, measure and record the X positions and the Y positions So here we see we're recording the distances between the probes. And the distance is the same between all the probes. Now we are measuring the y positions. So what was recorded previously was the x distances. Now we are measuring the y distances. Which is taken as from the top of the first line in the graph paper up until the tip of the probe. So here we can see it here, that the first one correlates with 0. So the datum line is the top line in the graph sheet in the back, which is being measured against. Right, and this is done for all the probes. The y positions are measured with reference to this datum line. Right, we are on the fourth one here, the fourth probe, the fourth y position measured. Fifth, followed by the sixth, and then the seventh. So we now move on to the next step, where we adjust the water height in the water column to the other height of 300 millimeters and repeat the entire process.